Bismillahirrahmanirrahim. Let us go into a new chapter. We are to evaluate this integral. Okay, so how can we evaluate? Definitely we cannot use the method that we have learned earlier. Okay, so this is what we'll learn inshallah today. So basically we are to learn another technique to integrate. We call it as integration by parts. This formula of the integration by parts is taken from the derivative formula of product rule. Remember, when we have multiplications of two functions, the derivative of it is fg prime plus gf prime. And when we are to take the entire derivative of this portion, okay, so this portion we take the derivative of it, and here we have a plus, so meaning we can separate, so become fg prime dx plus f prime gx there. And as we are rearranging it, this part, we bring it on this side, so we have this one and this one. Okay, so this is fg so this is fg f prime, and then here we bring it on the other side, become minus. So if you say that this f is a u, so du dx is f prime. Okay. And if we say that the v being the function g, so dv dx is g prime. Okay. So this relationship can be written in a form of f just now is the u, g prime dx is the dv, and f is the u, g is the v, minus f prime dx, f prime dx is the du, and the gx is the v. So it becomes a formula, and this formula is called the integration by parts. So when you are assigning your variable in terms of the u and the dv, so the tricky part is what would be the appropriate u. So there's a guideline here. So when you are choosing the function to become u, make sure that the function is easy for you to differentiate. As for the dv, okay, the function has to be something that is easy to integrate. And there's a guideline there, we call it LIAT. LIAT here is a guideline where the u will be the function whose category occurs first in the list. So between log and inverse, okay, you take the u to become the log function. And then the second will be the dv. So this guideline is not necessarily works every time, but this is very useful for us to follow. So for a start, let us evaluate this simple integral of x multiplied by sin x. We're going to use this integration by parts. So the first one is to choose what is the appropriate u and the dv. So according to the LIAT, okay, between log, inverse, algebra, trigo, and exponent. So here, if we analyze our question here, this is the algebra, and this is the trigo. Okay. So according to it, what will be the appropriate u? Okay, the algebra and the trigo. So we choose algebra to be the u. We start with that. And the remaining, the sin x dx to be the sin x dx to be the dv. You have to start with that first. Okay, and then after that, using this formula, you plug in your values such that just now the question u dv is uv minus v du. So how to get the u? U is easy. U is x. And v, how to get the v? Here to get the v, we integrate both sides here. As we integrate this dv, we get the v, and as we integrate the sine, we get the negative cosine. So now we replace this v into the formula. The v is a negative cosine, and then formula minus, initially minus, integrate v. V is a negative cosine, so negative, negative, positive cosine, and du. What is du? We need to get it from here. Du dx is 1, meaning du is dx. So replace the du there with x. So basically, this question now will be simplified. It becomes something like this. Okay, meaning now it's easy for us to integrate. Integrating cosine, we get sine, looking into your formula list. So hence, this is our answer. So basically, you just need to use the formula and plug in the values. Okay, but the hard part is to recognize what is the appropriate u and dv. So this is a nice guideline for us to follow. Okay, let's do more examples. So this is the class exercise. Okay, and let me put down the formula. Okay, we are to use integration by parts to solve the integral. And this is the guideline for us to choose the appropriate u. Right. As we analyze question number 1, for a start, let's do it together. Here we have algebra, here we have exponent. Between a algebra and exponent, so the algebra comes first to be the choice of our u. Right. So let's take the algebra, the u as u. Okay, the u as 2x, and the remaining e power x dx to be the dv. You have to carry the dx together because after this you are to integrate. Right, after you have got that, then you need to consider to find your du. Okay, du on dx, which is 2. So your du is 2 dx. Okay, we need this. And also, to get to your v, we need to integrate both sides. And here is this. We integrate. So we integrate both sides. Okay. After we have recognized what is the appropriate dv, so over to the left we get the v, and integrating e power x is e power x plus c. Don't write down from plus c just yet. Towards the end, then we will write down the plus c. So I'm going to erase plus c. Right? Okay. So as of now, we got the du. Let me highlight. We got the du. We got the v. Okay, and what was the dv just now? The dv is the e power x dx and the u. Right. So the formula, our question now, okay, if I am to write back my question, 2x e power x dx, the formula is, we put the formula u v minus integrate v du. Okay, put input. Okay, let's replace the values. U, what is u? U is 2x. Check my work. V, what is v all? E power x. Okay, minus, then we need to integrate. And the v is e power x. And what is du? Du is 2 dx. Let's put the constant in front and dx. Okay, now you can see it's easy for us to integrate now, right? So let's complete this. E power x, 2x multiplied by e power x minus 2. Integrating of e power x is e power x. Last one, then we put down the c. So here, maybe we can factorize. Okay, it's nicer to factorize here. So factoring, we will get x minus 1. Right? You can factorize, okay, or you can just remain as is. Okay, next let's look at question number 2. This is the formula for the integration by parts. This is the guideline for us to choose the appropriate u. Okay, if you analyze it, this is algebra and this is exponent. Between algebra and exponent, algebra comes first, meaning the u, the appropriate u is the algebra x. And the remaining, which is this 5 power 3x dx, is the dv. Okay, you have to have this one first. And then to have this formula being du, we need to find what is the du, what is the v. So for this case, we continue by differentiating this portion. So du, we get as dx. As for this portion, we integrate both sides so that we can get the v. And then, okay, how to integrate this 5 power 3x? We have to use the technique that we learned earlier. I'm going to use the u substitution. Okay, let's recall back on the u substitution. So I got this from your formula list. So how do we integrate, okay, this thing, right? So by using this substitution, we need to replace everything in terms of the w in this case. So how to differentiate this one first of all? Sorry, the w should not be the 5 power. Okay, the w should be a simple 5 power u. Yeah. So the w should be 3x. So as you differentiate dw on dx, we get 3. So meaning the dx is dw on 3. So this integral now will become much simpler. And say using this u substitution, I'm using variable w here. Okay, 5 power w. Okay, and dx is dw on 3. Let's put up front the 3. And this is the formula given in our formula list. We can just code, okay, integral of a constant power x dx. Okay, so we get b power x ln b. So the base is 5, our variable is w over ln 5. Don't yet put the c here. Later on towards the end, then we will put the c. So let's replace back our w, hence the v there. As we simplify, it becomes 5 power w is what? W is 3x over 3 ln 5. Okay, so there we got the v. Next, so this question, sorry, question number 2, let's rewrite back. So this question number 2. So hence, this question 2, x 5 power 3x dx. Using the formula of integration by parts, let's put back the formula. It is uv minus integrate v du. Okay, so we just need to plug in and replace all these values of the uv and so forth. So help me. U is x, v, we got this. Okay, let's write it down. Over 3 ln 5 minus integrate. We need to integrate further. The v is this. Okay. And du, where to get the du? Du is our dx. Alright, so then we are stuck with this. 3 ln 5 is a constant. Okay, let me put it up front. Okay, so let me rewrite it back. So how we are left with this integral of 5 power 3x? So basically we have found this integral of 5 power 3x by using a simple u substitution using w here. So the integral of 5 power 3x is this answer, right? So there we have solved it. Let's replace this value with this. Okay. I'm going to erase this formula. So basically when we replace this value of integral, we are solving it. Okay, there is no more integral that we need to solve. But this is quite complicated. Let's factorize it so that it can, it can look easy. It will look simpler. Let's factorize it. So there is the factorized form. It looks nicer, right? Okay, so we have solved question number 2. Don't stop there. Make sure you do more exercises.